These notes are for Algebra 3, Unit 2, Quadratic Equations, Section 1.4, Complex Numbers. So we talk about an imaginary unit, and a lot of students want to know if it's imaginary, why are we using it? But it's a concept that's used in many fields, one of them being engineering and electronics. So the square root of -1 can be directional, and it's kind of hard to understand that one. I'll just give you a little quick view of it. So if you have a coordinate plane, you're used to seeing that this is the x and this is a y. Complex numbers can be used as vectors, and they're directional and they have magnitude. So for what we're doing, I'm just going to tell you that this is going to be a, which is called the real part. So a plus bi, a is the real part. And this bi, I'm going to plot a bi here. Bi is called the imaginary part. Altogether, it's called a complex number. And if you only have a bi, you don't have a, say you only have 3i, then it's pure imaginary. So when you're looking at this a plus bi, you can go in a direction of positive a, or you can go in negative a. You can go positive bi, you can go negative bi. So when we're looking at this I squared equals -1, there's going to be a pattern. So if I just have I, we're just going to say that's I. So that's in this direction. If I have I squared is equal to -1. That's going to wrap me around over to here. So this is going to be -1. This is going to be a positive I. If I have I cubed is going to be I squared multiplied by I. So -1 multiplied by I will give me -I. So down here would be -I. And then I to the fourth will be, however you want to look at it, I think of it as I squared multiplied by I squared. So I'd have -1 multiplied by -1, which is to be a positive 1, which brings you back over here. And then the pattern continues. I to the fifth, I to the sixth, I to the seventh, I to the eighth. We don't spend time doing that. There's a couple problems that will show up. We don't spend a lot of time in that in Algebra 3. But if you did Algebra 2 with this, there's a couple ways you can look at it. First thing is, well, let me show you what happens. If I took the square root of -4, it tells me it's a non-real answer. So what I need to do is I want to go to my mode, and I'm going to come down here to where it says real. I'm going to go over to highlight a plus bi, and I'm going to hit enter. Then when I come back and do the square root of -4, I get 2i. So if I were checking these powers, say if I have I, and I'm using the second and then the decimal point, I'm using this point right here, so you see the blue I right below or right above it. That's what I'm pushing for, the I value. So let's do I raised to the 5th power. It's I. And the calculator will do it. But then if I did certain numbers, if I did I raised to the, say, 27th power, then it gives me this really weird answer. -3 times 10 to the -13th I. So I to the 27th equals -3 e -13 minus I. I could do this one of two ways. I could recognize this scientific notation is saying -3 to the -3 to the -13th power. Let's make that better. So -3 times 10 to the -13 means I'm going to take and move this decimal place over 13 spaces, and I'm going to run out of room. So basically, this is going to be -0.00000, and a lot of zeros and a 3. So this is going to be basically 0. I don't need that. So my answer just becomes -I. And you can count this out if you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. and I stopped on negative I. Or you can recognize that this goes in patterns of 4. So 27, if I go it through 4, 4, 8, 12, 16, 20, 24, and then, so this is 25, 26, 27. And like I said, we don't do a lot of that. I just kind of wanted to bring it up at this point. So now my examples, if I wanted to simplify, so I want to reduce complex numbers to the simplest form, and I might just take the square root of 81, negative 81. I just recognize that this is the square root of negative 1 and the square root of 81. 81 is a perfect square, so I'd have I times 9, and it's typically written as 9I. Same thing with this negative 147. It'd be the square root of negative 1. 147 breaks down into 49 times 3. So I have I times 7 times the square root of 3. It's typically written as 7I square root of 3. And the main reason it's written like this, the I is usually before the square root symbol, before the radical, so that you don't think the I is underneath the radical. Adding and subtracting with complex numbers is very simplistic. You're just going to take the real part and combine them. So 3 plus 5, those are my real parts. And then 8I plus a negative 2I. And when I combine them, I get 8. 8I minus 2I would be positive 6I. And you can check this in the calculator. It's really easy to check. So I would just type in, let's see, 3 plus 8I. And I'm using the parentheses just like I have it there, plus 5 minus 2I. So I get 8 plus 6I. To me, it's not worth picking up a calculator for simple problems like this unless I really think I might have made a mistake. I would use it more for the harder problems. This 2 minus 7, so that's the real part. And then I have 9I minus a negative 3I. So minus a negative makes it a positive. 2 minus 7 would be negative 5. 9I plus 3I is 12I. Now multiplying is a little bit more challenging, but you just have to be very careful. So my first example, I'm going to make sure that I distribute. This parentheses multiplied by this parentheses means I'm going to have to distribute or FOIL. 7 multiplied by 5 is 35. Outside, 7 multiplied by 6I is going to be positive 42I. Negative 2I multiplied by 5, negative 10I. And negative 2 multiplied by 6I will be negative 12I squared. I can combine these middle terms. They're like terms, so 35 plus 32I. I'm going to replace I squared with negative 1. And that goes all the way at the very beginning of the notes. I said I squared is equal to negative 1. So I'd have 35 plus 32I, and negative 12 multiplied by negative 1 would be a positive 12. Now I can combine 35 and 12. I get 47 plus 32I. And I would double check that. Type of problem that a lot of students will make mistakes on is when they see a term squared or cubed, they just start multiplying numbers and not thinking about what they're doing. So I would always recommend anytime you have something squared, write it twice. Now I can see it a lot easier. 1 multiplied by 1 is 1. 1 multiplied by negative 8I is negative 8I. Negative 8I times 1 is negative 8I. Negative 8I times negative 8I is a positive 64I squared. In mathematical terms, you can see this is a minus b squared is going to equal a squared minus 2ab plus b squared. This is a perfect square trinomial, and we'll talk about this later. In math, there's a lot of patterns, and if you can recognize patterns, it makes your work a lot simpler. I'm going to combine these two like terms now, so I get 1 minus 16i. I'm going to replace the I squared with a negative 1. So I get 1 minus 16I minus 64. 1 minus 64 would be negative 63 minus 16I. And I am careful to write it in standard form, A plus BI. Always have the real part first and the imaginary part second. It's like having the X before the Y. This next one is more complicated. It's a lot more advanced. I'm going to go ahead. I have the square root of negative 4. I recognize that as 2I plus the square root of 3. Square root of negative 25 I recognize as 5I minus 6 square roots of 3. And I'm still not done. I'm multiplying these two binomials. So now I'm going to multiply 2I and 5I, and I get 10I squared. 2I multiplied negative 6 square root of 3 is going to give me negative 12I square root of 3. Remember, outside times outside, inside times inside. Then I'm going to multiply the square root of 3 times 5I. So outside is 5I. So plus 5I. Inside is square root of 3. Then I'm going to multiply the square root of 3 and negative 6 square root of 3. So I'm going to have negative 6. Square root of 3 multiplied by the square root of 3 is going to be the square root of 9, which becomes 3. I can combine these like terms here. So let's start at the beginning. 10I squared, the I squared is negative 1. So I'm going to replace the I squared with negative 1. Combine these like terms, so I get negative 7I square root of 3. And I'm multiplying the 6 and the 3 together, and I get negative 18. This is going to be negative 10, and I have a negative 18, so I get negative 28 minus 7I square root of 3. And to check this with a calculator, you're going to get a decimal. I can show to you. Let's do parentheses, second square root of negative 4 plus the square root of 3. And careful, you have to be careful how you're doing your parentheses. Notice where the radical ends. You do have to be very careful and watch what you're typing. So I have the square root of negative 25 minus 6 square root of 3. And I'm going to get this weird decimal. I don't care what it is right now. I'm just going to compare it. Then I'm going to get negative 28 minus 7I square root of 3. I'm just comparing to see if I simplified it accurately. And I did. I got the same decimal in both places. And after I've checked it, that's when I tend to put a box around my answer. That way I know I've checked it. Okay. The other thing that happens with complex numbers is we talk about complex conjugates. So we talked about conjugates with radicals, and now we have complex conjugates. So if I had A plus BI, a conjugate would be A minus BI. If I have A minus BI, a conjugate would be A plus BI. All I'm doing is changing the sign in front of the imaginary part. So this negative 3 plus 8i, the conjugate becomes negative 3 minus 8i. I don't change the sign on the real part, I just change it on the complex part, on the imaginary part. So this positive 1 stays a positive 1. I'm going to change the sign on the imaginary part. So 1 plus 4i. So in these next problems, you'll see the purpose behind complex conjugates. I want to divide complex numbers. And when I divide complex numbers, I'm really just looking to rearrange this so that there aren't any complex numbers. There's no imaginary parts in the denominator. So what I'm going to do is I'm going to multiply by the complex conjugate. So I have 2 plus 3i. My complex conjugate is going to be 2 minus 3i. Whatever I multiply by at the denominator, I have to multiply at the numerator. To me, that's the most important step. After that, be careful with your math, but the first step is the most important. 9 times 2 is going to be 18. 9 times negative 3i will be negative 27i. I'm going to multiply my denominator. 2 multiplied by 2 is 4. 2 multiplied by negative 3i is negative 6i. 3i multiplied by 2 is a positive 6i. And 3i multiplied by negative 3i is going to be negative 9i squared. My numerator, I can't do anything with it, so I have 18 minus 27i. My denominator, if you'll notice, I have a negative 6i and a positive 6i. Those are going to add up to 0. And that's exactly why I've chosen the complex conjugate. If you do this right every single time, you're going to get rid of the I. So my denominator gets 4 minus 9 times negative 1. I replace the I squared with negative 1. So I get 18 minus 27i, 4 plus 9. So I get 18 minus 27i over 13. And it's perfectly fine to leave it like that. If you're more comfortable, you could write it as 18 over 13 minus 27 over 13i. Either one is fine. There's nothing wrong with leaving it like that. The next one, I've changed a couple little things, but I'm still first looking at my denominator. 3 minus 5i, the conjugate will be 3 plus 5i. But whatever I multiply at the numerator or the denominator, I have to multiply at the numerator. So now I'm going to just multiply carefully. 4 multiplied by 3 is 12. 4 multiplied by 5i is going to be plus 20i. 2i multiplied by 3 is going to be plus 6i. 2i multiplied by 5i is going to be plus 10i squared. And then at this point, I've done enough of these. I understand that my middle terms are going to cancel out. So I'm just going to go ahead and multiply. 3 multiplied by 3 is 9. I'm not going to worry about the 15i and the negative 15i because that's going to be 0. Negative 5i multiplied by positive 5i is 25i squared. Clean up now whatever you have done. So I have 12 plus 26i. I don't like the 26. Let me make that nicer looking. Plus 10 times negative 1. 9 minus 25 multiplied by negative 1. Since this is a negative 10, 12 minus 10 will be 2 plus 26i. 9 plus 25 will be 34. And if you recognize this, 2 and 26 and 34 are all divisible by 2. So I would write this as 1 plus 13i over 17, or 1 over 17 plus 13 over 17i. I preferred that, but it doesn't matter to me. And then the last example I have, it is a lot more complicated. Just have to be careful. You're capable of doing it. You just have to go slow and make sure you know what you're doing. I'm going to write this first as 6 divided by 3 plus I square root of 2. Now I can multiply by my complex conjugate of my denominator. So I'm going to multiply by 3 minus I square root of 2. But whatever I do in the denominator, I have to do in the numerator. Just multiply carefully. 6 multiplied by 3 is going to be 18 minus 6i square root of 2. When I multiply my denominator, 3 multiplied by 3 is 9. I remember my middle terms are going to cancel out. So minus 3i square root of 2 and a positive 3i square root of 2 is 0. So I'm going to have minus I squared. I multiplied by I. Square root of 2 multiplied by square root of 2 is the square root of 4, which is 2. So my numerator, I have 18 minus 6i square root of 2. I squared gets replaced with negative 1. So negative 1 times 2 is a positive 2. So I have 18 minus 6i square root of 2 over 11. Find a stop there. If you want to continue, it can be 18 over 11 minus 6i square root of 2 over 11.